third thing about brittle fracture is you're going to end up with a flat surface, fracture surface. We saw that from a picture I showed you earlier. Right here. Let me add this picture. Yeah. What do I mean? Flat surface, that's, if you look at the middle one, this two. It's fairly a brittle material, so we'll end up with a flat fracture surface. Okay. Another thing characters about brittle fracture is it may have a V-shaped, it's called Sharon markings. Find a picture to show you that. No. Okay. A good picture to show you right here. Let me see if I can copy this. Copy. Paste. Great. Right. Okay, this picture shows what is that V-shaped chevron markings. Can you see that? Can you see the V's? Let me highlight the V's here. In both figures, you can see that V-shaped markings. All right. And for those two pictures, here is the origin of where that initial crack is. Okay. And there are other types of fracture surface under brittle fracture. And sometimes there's lines or ridges that radiate from the origin of the crack. Oops. Crack. All right. You should find a picture for that. Okay. All right, can you see these two pictures? Do you see here's the origin of that crack. Here's the origin of the crack of another image. And as you can see, there's radiation, the marks that radiates from the origin. It's like a fan-like marks, all radiates from origin all the way through the material. Same thing for this. This one is lines and ridges. This one is fan-like. This one is lines and ridges. So actually there's a a group of people, their job is to study the surface, fracture surface, and it will tell the company what is happening for the material. So it's actually a full-time job. People do that. Use microscope or scanning electron scope to look at the surface, and it will tell the company what is going on with that material, why the fracture will occur. So it helps the company to improve their products. That. So that, if you're interested in, you can look that up. That's called fracture-graphic. These studies of fracture surface. And the tools they use is called the SEM. Remember what is SEM? That's a scanning electron microscope. All right, that's about everything about brittle fracture. So next time, if you see a picture of a fracture surface, you need to be able to identify what type of fracture is that. So brittle fracture is very easy to identify. The sign is either you see the lines or ridges, or you see a fine-like pattern start radiates from the origin, or if you see a V-shaped markings, those signs tells you this is a brittle fracture. Okay. So far we have been talking about fractures in brittle material. And what is happening for other type of material? That's something we're going to look at today. So another type of material we're going to look at is called amorphous material. Oops. So question is, what is amorphous material? Not crystalline. Yes. Now, what is a crystalline material? Not amorphous material. That's a dead loop. So as we know, if something is crystalline, that means it has crystal structures, either FCC, BCC, or HCP, or maybe some other crazy type of crystal structure. And for amorphous material, it doesn't have any crystal structure. It's like totally random and no certain pattern, no pattern. The thing we learn about the crystal structure, it has a certain pattern, right? But for amorphous materials, there's no pattern. A good example, do you know any examples of amorphous material? We have a lot in this classroom. Hmm? Yes, glass, it belongs to ceramic material, but that glass doesn't have any crystal structure. So it's totally random and there's no pattern. It's a good example of amorphous material. And another example in this classroom would be most of the polymer or plastic materials. The tabletop, your pen, your pencils, those plastics, most likely they don't have crystal structure. So what is happening? What does the surface look like for amorphous material? Let's give a guess. If we break that window glass, what would happen? How that fracture surface going to look like? Of course, don't do that experiment. We'll be in trouble. but you probably broke glasses since you grew up. Everybody broke some glasses, right? Who can tell me how that fracture surface looked like from your memory? Very flat and sometimes very shiny. What? What is shards? Okay, yeah, it breaks into different pieces, but when if you look at the surface, the fracture surface, how that looked like? No, never pay attention to that. Okay, so if you break, you can go home and try that. Break a piece of glass, you will look at the surface, you will find out it's relatively shiny and smooth. Yeah, the very easy experiment would be just crack your phone screen, right? Yeah, that's very easy to do. And that's a scan. I think all the smartphone companies, they put a very brittle material on your screen on purpose, right? That's a scam. That's how they earn money. They can use different materials. Everybody knows brittle material is gonna break if you just drop it on the ground or something, apply a force. But they still use that material. And they claim this is the strongest glass ever used on smartphone, but that's a scam. There are other alternatives you can apply, but they won't because of money. Okay. All right, that's amorphous material, such as glass or other ceramic materials. Or sometimes you will find that from very brittle polymers or plastics. Okay, that's amorphous material. I don't have a picture to show you, but you can imagine that. Now let's look at what is going on inside of crystalline material. Okay, now I want you to guess. In an amorphous material, a material doesn't have any crystal structure. The fracture surface is flat and smooth, it's shiny. So what happens if you break a crystalline material? That means a material has small grains inside. Okay, I give you 2 minutes, talk to each other to think what would happen for crystalline material, where that fracture would occur. Okay, if you look at the screen here, I have a picture of crystalline material. Can you see that? So one question as a review, what is that, the lines in between the blocks? What's that called? Green boundaries. Yes, that's the most important thing for engineers. Green boundaries. So each grain, so we have more than 10 grains probably inside. Each grain, inside of each grain, it's a single crystal, right? Each inside of each grain is a single crystal, which means each grain gonna have different orientations in terms of their crystalline structure. And I want you to give me a guess. Tell me if this material breaks, how that break look like, how that fracture surface look like. Any guesses? Mandy? Follow the green boundaries. Break on the boundaries. So that if we draw that, if a crack happens, use wider one. Oops, that's too much. Let's follow that green boundaries. Here we have a choice, either go up or go down, doesn't matter. Boom. Imagine if this piece of material breaks along the green boundaries. That's possible. That's one of the possibilities. Actually, we have a name for this. So this, it's called intergranular. So this type of fracture is called intergranular. So that cracks propagation, it's along the green boundary. Okay. So that's the first type of crack inside of crystalline material. That's a weird word. Intergranular. That's along the green boundaries. Well, if we can have crack along the green boundaries, of course we can have cracks all the way past through the each grains. So there's another type of cracks in crystalline materials that cracks won't follow any green boundaries. It just cross through the grains. And this type of fracture is called transgranular. So cracks propagate by breaking atomic bond along a specific crystallographic plane. You can imagine for this type of fracture, transgranular fracture, it requires more energy because it has to break so many bonds. Imagine inside of each grain, there's so many atoms. You have to break the bond between each atom. And that direction depends on the material. It follows certain crystallographic planes. A review here, how do we write out the indices for plane? Which notation we use? Do we use square bracket or curly bracket? Which notation we use for plane, crystallographic plane? Square one? Which one? Which one is for direction? Wait, which one is for point? Nothing, just 3 numbers. Which one is for direction? Parentheses for direction. Then we only have one left, which is square bracket for planes. What is happening when you have curly brackets? That's a family, yes. Okay, all right. Yep, that's the difference. Under crystalline materials, we can have 2 different types of fracture surface. All right, let's see if we have other pictures for that. Nope, I don't have pictures for that. Great. All right, any questions? That's everything we need to know about fracture surface. Let's do a quick recap here. For very brittle materials, and we could have relative flat surface with either V shapes or ridges, lines of fan-like patterns. For amorphous material, such as glass or other ceramics, we can have a very smooth and shiny surface. For crystalline materials, and the fracture can occur along the grain boundaries. That's called intergranular. And I hope you memorize that. That's a term you must memorize. What does that mean? And that could be a very good true and false or multiple choice problem. Same deal here. If the cracks is passed through the grains, and we have, this is called kind of like transpass a grain, right? That's called transgranular fracture. Okay. All right. Any questions on different type of fractures? If not, we're done with fractures. I have a couple of videos I want to show you. The next topic we can talk about is called fatigue. All right. Okay. So let's learn what is fatigue and how to do fatigue test.